All right, what we're working with today is congruence and transformations. The first thing we have to know what it is a congruent figure. We've talked about it some because we've said that there's some transformations that are rigid. And remember, rigid just meant that they stayed the same size. Well, same size is congruent. So if I have a triangle that looks like this, and then I translate it, it's going to look exactly the same. And so the left side is equal to the left side, the bottom side is equal to the bottom side, and the diagonal side is equal to the diagonal side. Okay, and so that's what congruent figures are. When you transform them by translations, rotations, or reflections, they stay the same size, and so they stay the exact same. Your congruent transformations, again, are reflections, rotations, and translations. Those are the three things that maintain congruence, and that's why they were called rigid, and we had already learned some about that. All right, so let's just look at the two examples because that's all we really have to do. So determine which figures are congruent. Okay, determine which figures are congruent. Describe their transformation as reflections, rotations, or translations. Okay, so let's look at this one first. I'm going to look at 4 and 5. So 4 and 5 are the same, but they're rotated and they're kind of flipped. Okay, so to get from 4 to 5, I could translate and then rotate. So from 4 to 5, I would say that this is a reflection because it reflected over here and then it rotated down. Actually, that's just a rotation. There's too many shapes on here to see, so this is a rotation. Okay, let's look at the next one. 1 to 7. That also is a rotation because it stayed on the same place, but it just rotated to this axis here. So this is a rotation. But then if I could go from 1 to 3, 1 to 3 is a translation because it moved to the right and up. And 7 to 3 is also a translation. So that takes care of our little squares. Okay, the last one we have is our triangle. Kind of run out of space. Where's my red? There it is. So my triangle from 6 to 8. Okay, this happens to be a rotation. It rotated around, but it actually slid too. So it's a rotation and a translation. So problems like number 1, I'm just wanting you to describe what happened. I'm not actually asking you to tell me exactly just which one of those 3 things happened. Okay, all right, let's look at number 2. Let's get a different color. So for number 2, this is a rotation, and you can see C to C prime. I have to solve for X, which is AC. Well, that's going to be the same as the AC here, A prime, C prime. So since those are the same, that's my equation. 5x plus 3 equals 23. Subtract 3 on both sides, and I get 5x is 20. So I divide by 5, and x is 4. So because they're in the same place, they're congruent. So for congruent transformations, you just have to know kind of what happened and if it maintained congruency. And then if it did maintain congruency, you need to be able to write an equation based on the image and pre-image, and what's in the same location must be equal.